Uh, Hi, everyone. I'm probably the most incompetent developer over here because most of the examples of failures that you'll see, although I won't name the developer, you can guess after having heard me in the speak. Uh, I'll be talking about trade-offs in distributed systems. There's a lot of trade-offs that we do when we are building products. I mean, every time in life we keep doing trade-offs, but in distributed systems, especially there's a particular way in which you can tell that these are the trade-offs that you'll be doing. For example, consistency, availability. How many of you have heard of the CAP theorem? Okay, good show of hands. How many of you have worked on distributed systems where there's two databases in different places in the world? That's like 5, okay. Okay, this is going to be fun then. Okay, yeah, enough about me. Okay, what is a trade-off? We have spoken about that, okay. All right, so how many of you can identify at least one example from here? These are all back-end system trade-offs. Pull versus push architectures. At least one? Yeah? Lossy versus lossless. How many of you are from college, fresh out of college? Okay, JPEG, anyone? Lossy, yeah. So interestingly, when you're aggregating metrics, when you're saying how good a system is, sometimes you need to measure what's its performance. Right? And at that time, what you need to do is you need to store that kind of data. So for example, let's say the number of sales you make in one day is 10, the next day is 20, the next day is 30, and so on and so forth. You can store all this data, or you can take it in a week, aggregate it for a week, and then store it. Which one would you prefer? You can do this in a notebook also. I mean, it's the same thing. Every day you're just noting down sales. You can make a graph out of it. Or you can make it a weekly graph. What are the advantages of having a weekly graph? Okay, I know the answer. I'll tell you. So in a weekly graph, first of all, the number of points is lesser. So storage is lesser. Yeah, it makes more sense sometimes because some sales are weekly, like Saturday, Sunday, all the sales like in a restaurant. So it makes sense if you want to save data, but it doesn't make sense if I'm starting to get a feeling that this is how the thing is going to go. Like, can anyone tell me a disadvantage of aggregating metrics and then storing them instead of having them point by point? I'm sorry? Yes, loss of some information. So if you had a day where you had a serious problem, you don't really know whether it was Wednesday or Friday. Okay, pretty simple trade-off. We'll get to the complicated ones soon. 3 examples I'll be taking in this presentation. There'll be performance versus complexity, where you want more performance out of the system versus how much effort you're ready to put in. So if you make the system complex, usually you get better performance. Performance versus accuracy. This is a little different in the sense, if you want, like we were talking about weekly aggregates, accuracy is lesser, but it's more performant. In the sense, you require lesser space and lesser time to pull out that kind of data. And finally, pull versus push architecture. This is a little complicated. I'll get to it and then explain. OK, what will you get out of this? Almost every distributed system has some sort of trade-off. And as we'll see, we will be able to identify these trade-offs much better. We'll be able to make decisions such that we can meet our requirements then. OK? And what won't you get out of this? This is more important to tell you because in case you actually follow any of these things that in the presentation that I'll be saying, and then go and apply it in your company, and then you get fired or something, then I don't know. I wasn't there. OK, the first thing that we have is a stuck task server. Okay, there's a worker, it does tasks, and there's a task manager. All right, the task manager does one thing, it says, do this task. When the worker's done, it just notes that down in its own database. All right? It's a pretty simple system. Now, we had a problem. We had a problem that the worker sometimes did not know that the task is finished. It would die. So it wouldn't notify us. I was handling the task manager, writing the code for that. And so the task that I was given, I mean, the job that I was given was go to the worker and write down some code, a script, which will just notify us on the task manager that this job is done. Okay, the Git guy is laughing a lot, but is the scenario clear? All right? All right, so I wrote a small script in Python. It worked well. Then, as usual, the requirements changed. So the DevOps team came to me, and they said that it should recover on crash. So I wrote a small Unix script for this so that it reruns the Python thing again and again. Then they come and tell me that there's conditional logic, that if the task was more than 3 hours old, then we should put it in a log or something like that. And it started getting complicated. Finally, the invoice service came in. Every task that we do, we take money. You can actually imagine these guys to be our clients. They are telling us to do some computational work. We are doing it. We are noting it down. This is like the auditor. And we have some sort of invoice service which is telling us that how much money we should bill them. Okay. And whenever money comes in, it becomes a little risky. No longer can I just do some script and get away with it, because the invoice service is going to be charging based on the amount of time required for this task to complete. Is this bit clear? Okay. So I ended up with a state machine in the task manager. And overall, at the end of it, if you go back and see the original diagram, and you see this diagram, there's about 3 months of difference. We made a trade-off over here in this whole process. What do you think the trade-off was? Like, initially, I did something so stupid. Not my fault, of course. But I did something pretty stupid. I just wrote a very simple script which didn't handle most of the use cases. And then it kept getting more and more complicated. Am I audible? I'm sorry. Oh, sorry. The mic is sticking to my face. Yeah. It's not a distributed system trade-off. It's more of a cultural trade-off or something that the management should be seeing. Sorry? The initial thing was too simple. And we keep getting told as developers that keep it simple, keep it simple. We shouldn't keep it simple. We should keep it extensible. Like, being lazy is not really a skill. Being lazy is a tool. You should use it as much as you can by keeping things extensible. But you don't need to be lazy for no reason. Yeah, I was lazy over here. It took forever. It cost a lot of dev effort. Initially, I was writing the script. We had to turn it into Java. We had to bring in 5 devs and actually get this done in 3 months. We would have taken lesser money and lesser time had we paid attention to simplicity versus extensibility. Yeah, extensibility is more important than simplicity. That's the first trade-off that we are talking about. Okay? Who was that? Someone just said no. Okay, the postmortem, I mean, there's lots of things that I did wrong here, but the most important ones were the ones that I just mentioned. Okay, all cultural. We can change that by changing our mindset. Whenever we are given a task, just dig around, figure out what are the possible problems that can come up in the next 6 months, or maybe even 3 months. You don't need to go that far. And once you have those, make sure that you're taking care of them. Okay? Okay. The third point in this is probably the most important, the steps that we could have done to mitigate this. When I came up with this solution first to my management, I should have been told that this is not going to work. I think I'm putting too much blame on the management. Maybe I should take some of it myself. But okay. I was also at fault. I should have automated things and measured how much time is it taking every day to do the same thing again and again. As a developer, it's my primary responsibility to automate things. Okay, by the way, this is interesting. So we had a senior who was then given this job. Like, Gaurav has screwed up as usual. So a senior came in, and they started saying that, I'm going to rewrite this. I'm going to refactor and rewrite it so that more functionality can be added in. So this guy used Python 3. Okay, and then he said that, I'm going to put multi-threading. I'm going to put level logging. I'm going to do lots of stuff, retrials and all. Then the DevOps guys in our company, they had conflicts. They used to use Python through 2.7, and we are not having containers or anything like that. So we had a conflict with them. They said, you can't deploy. to my senior. And then comes the real thing. When the Python version did get updated in the boxes, my code was more up to date because it's on prod, so I had to keep on changing it. And that guy's code was not up to date, so it never went on prod. I felt like, yeah, my code sucks, but it's on prod, yeah? So this is the main thing. I mean, if you go on the other side, you go like, it should be extremely extensible. Like 6 years down the line, it should still work. It's not going to work. Most likely, your code will never reach prod. Okay. So yeah, Brad Pitt agrees with me over here, of course. I actually asked him this question, and he immediately came up with this meme. All right. The second example. How many of you know what an IPO is? Everyone nearly? Yeah. So you go to the public, the first time you're offering some shares, you get money for that, and you're happy. So in one of my former companies, they used to do this, and it was a huge company that we were dealing with. Okay, Facebook level scale. So they put their initial public offering out. We said that, okay, I think the price of one share is X dollars. So people started, I mean, the IPO has just happened. People are thinking about it. It's going normally. But the price we set was pretty poor. We thought that it will sell for, let's say, $10, and people were not ready to buy it at that rate. At this point, what happens very often is that the investment bank says, I will buy your shares because I'm confident it is worth $10, and the market will catch up anyway. Plus, I'm going to nudge the market so that it starts buying shares. Okay? So we did. But there was a small problem. When we did, we saw a spike, a huge spike. Seeing this, of course, we are not alone in the market, so there's a huge spike. Everyone sees that this share has suddenly climbed up in its price. Maybe it's a really good share. Everyone started buying it. And our job is to keep the price somewhere around, let's say, $10. So we started selling. And everyone saw that they're selling, so this share is not reliable. So sell it. Anyway, all this is a disclaimer, okay? All this is a lie. It didn't happen in real life. But so the IPO was a disaster, okay, for a pretty big company. Now, why did this happen? Can you guess? You can't, but I just want to hear while I adjust, this thing over here. Can you guess why this happened? Sorry? The initial price was very bad? Yeah, but I always blame the bankers. But what's our fault this time? You know about the TCP protocol? You send a message, you get acknowledgement, and then you start sending data. So you send data, and every time you send data, what happens? You get acknowledgement? What if the acknowledgement doesn't come, though? I'm sorry? This guy owns a company. I can't believe it. But I'm just joking. But no, it's TCP. And we have no choice because it's a national stock exchange, and they are providing TCP. And they're saying, like, we will give you acknowledgement. Sometimes we may not give you acknowledgement, so what? What's the big deal in that? It's just money, after all. So the acknowledgement didn't come. What do you think we did? And we are smart developers, so we retried. So we said, let's say buy shares worth $1,000, and then we retried buying the shares worth $1,000. And let's say the first request was a success, but they could not send us acknowledgement. In this time, you have bought $2,000 worth of shares, right? And we retried 50 times. So that's the reason why the huge spike came, and the thing was a big failure. The postmortem was funny because the document was really detailed when they came up with the document saying that why we are sorry and why we should have done better. They said that we should have tested the system better. There were no validations before you just made the last thing. Nowadays, it happens a lot in financial systems. Just before you make that last call, right, that yes, buy, there's one external system in the same company, but it says that yes, go ahead or don't go ahead based on prior data. So make sure that it's not a complete goof up. This wasn't there. We assumed idempotency. Like you send multiple requests, it just runs once. That is called idempotency. Okay? And rate limiting was not there. We should have sent one request. 2 seconds later, send one request. 4 seconds, one request. This is exponential backoff. Yeah. But the steps to mitigate this were, they were all noted down. What do you think the management chose? Get the hell out of my office. I don't want to see your TCP or UDP or whatever you have with me. I just lost money. You can leave. So yeah, it was pretty bad, actually. I shouldn't make fun. But I wasn't fired, so it's OK. OK. So I'm sorry. The trade-off here, can you tell me what the trade-off was? Let's move back before, yeah, thank God. The trade-off is off the slide now. What's the trade-off that the engineering team made? It's in one of the solutions, actually. It's in the first solution. If you get it validated by an external service, what happens? Latency? That's exactly the thing. They were so obsessed with microseconds, nanoseconds, that they were just talking about, it's going to take time to buy that share. What if some other company buys it at that price? And we'll miss out on that opportunity. So they ended up buying it 50 times. But yeah, this is one of the reasons why they hadn't actually taken this into consideration, an external service. So we are talking about performance versus accuracy. We could have been more accurate. We chose performance. It's a trade-off. OK. How many of you have worked with graph databases? None? This doesn't have anything to do with it anyway. So you have a graph of users. They're all connected to each other. And what you want to do is you want to find your friends of friends, something that Facebook suggests. Given a user ID, find me the friends of this particular user. OK, so one of my friends came up with a solution which took 40 minutes to run. They had a BFS algorithm written down. And the required completion time was 1 minute. What do you think the problem was here? Yeah, it's going to be obviously very complicated, and then I'll pull something out of the blue and be like, that's a problem, yeah. But any guesses? If someone comes to you, this is what happened to me literally. He came to me and told me that, can you improve my algorithm? Can you improve my BFS algorithm? He did not tell me the use case. Most of the times you'll get this in the dev community that a person comes and tells you, how do you sort an array of integers? Instead of telling you what you really want to do. OK, so I said that you can use a bidirectional BFS. You can use a graph database. You can do lots of stuff. But actually what was happening, I'm sorry. Actually what was happening was the server that he had, his local computer, which was running in India, was making a query for every user to find its friends to the US, which was taking around 1.5 seconds per query. And you had like 17,000 queries that you were making. So that's the reason why it was taking 40 minutes. Anyone know a stored procedure, what a stored procedure is? Yeah? How many of you know what a stored procedure is? OK, a lot of people. It's like a program in a database. You just make that function call, and it runs, and it gives you an output. That's what we did. It came down to less than a minute, 40 seconds. OK, there's no trade-off here. I just wanted to say this story because I was like, I need to sound cool or something. OK, finally, we come to the system design trade-off. This is what you deal with in a distributed system very often. You have group messaging. Chat systems, anyone? How many of you have worked on chat systems? I'm sorry, I'm making you raise your hands all the time. Like, you should keep one like this or something. OK. On the server side, this is something what it looks like. We are going to be focusing on this bit. OK, just the chat, not the Tinder matches and all that shit. There we go. So you have a gateway where people connect. They make sessions. All right? Then we store the information of the session, meaning that where is this user connected? This box is one box. There might be 5 boxes for the same gateway service. So we make sure that in the session service, user Gaurav is connected to box A, user Arthur is connected to box B, and I don't know anybody else in this conference. OK, so let's say I connect here. The gateway service is going to tell the session service that I'm connected to this box, A. Similarly, let's say some other user connects here. The gateway service tells the session service that this person is connected to box B. Okay? Now, how do you think messages will go? This is one-to-one messaging. I have a feeling I've bored you all to death already. Take a guess. I'm sorry? So, I'm connected to this box. Let's say you have divided this into 3 sections, section A, section B, section C. I'm connected to section A. The session service knows about this. This is a normal chat system where one service notes down where you're connected. I'll just give you the solution, and it'll become much clearer now. The problem is whenever I send a message, this gateway service does not know who's connected to which place. If I start putting information of who's connected to which place in the gateway service, its memory is very expensive. I don't want to be wasting not just its memory, I also don't want to be writing all that complicated logic in this service itself. I want to separate that out, decouple it, and put it over here in the session service. Okay? So I sent a message to the gateway service. Gateway is like, I don't know where B is, or I don't know where this guy stays. So I'm going to be passing this out over here. The session service knows where B is, so it sends that message back to the gateway service, and then it goes to user B. This is how you do one-to-one chat in any application, usually. Is this part clear? You just go from one place, and it's like a tunnel. Okay. Groups. And this is where we'll get to the trade-off. Group messaging is more complicated. One person wants to send a message to many people. What happened? Yeah. I want to send a message. Can I send it directly to the session service? Why not? If it has the information for the groups, yes, I can. If it doesn't, then the session service doesn't know who all are belonging to this group. So initially, it has to go to the group service. The group keeps information of which user is connected, which user belongs to which groups. Okay? So I sent a message to some group. The group messaging service knows who are the people who belong to this group. And now, the group messaging service doesn't have that logic that it's going to talk to this guy. The only person who talks to the gateway service is the session service. All right, so it sends a message to the session service, but how many? Just one? For all users, yes. So I'm going to be assuming that 2 users. This guy is also connected. So it sends 2 messages. The session service then sends those messages to the gateway service, and finally it comes over here. Okay, this is how group messaging is done, and this is called the push mechanism. Can you tell me why there's a push over here? The trick is over here. Who's doing the pushing? The session service, yes. This is really good, because when you have direct messaging, especially, you want the message to go immediately. You don't want to waste time. So you push the message, the person gets the message immediately. That's a big advantage. What's the disadvantage possible for a group, especially? Think a lot of requests, yes. It's one of the reasons why WhatsApp has just 200 as your max limit. One of the applications that I worked on did not have a limit. We used to actually take these messages in batch and then push them. In batch meaning 50 and then the next 50 and so on. Any other optimization that you can tell me over here? Okay. I'm sorry? Single request, yes. You're doing some sort of compression. You don't want to send all that information through the network. Just send a single request with all the users. Session service will also send just a single request, and then this can expand on that and send it. Not much savings, but something is better than nothing. A client? The client itself will know about the group. Which client? These guys? Yeah. But then who will be doing the forwarding? Okay, so one thing I can do is, this person knows that there are 50 users in the group. They have that in their cache. They send 50 messages to the session service. Is that what's going on? Yeah, bundled. Okay, bundled, all right. And then bundled, we send it to the session service. Bundled, we send it back to the gateway service. And then you have to broadcast. Correct. You can have it on the client, but why would you like to have it on the client? You have this thing that people got promotions for, right? Group messaging service. I wrote a doc on this. Yeah, I want a promotion now. So keep it on the server, rather. Push? Yeah, push is. What about pull? Can you guess? Long polling, okay. Yes, but that's fine. I mean, we are talking on HTTP or XMPP. Both clients usually have that kind of support that they can talk on these protocols. But in general, the pull mechanism, can you guys guess what's going to happen here? Earlier, the session service used to push things. That's a hint, by the way. You can pull. You can pull from the session service. So let's say this client comes up. They say, come to the gateway service. Give me the messages which belong to me. Give me all messages which belong to my group. Similarly, this guy comes up, pulls the messages. And that's it. Anything missing here? Yeah, even this guy calls. All the clients are constantly connected, keep pulling for messages. Okay, what's going to happen here? A lot of resource consumption. You have all your sockets being used up by people who are like, do I have a message? And then there are other people who are like, I'm also waiting for mine, by the way. I'm sorry? Every? Yes, heavy load on the gateway service. And if you have millions and millions of users, it's going to be a problem. Okay, so what is the benefit of pulling, though? I think you already spoke about the disadvantage of pushing. Or did we? We didn't really. This is a group messaging service. What if it was Instagram? And Amitabh Bachchan just posted a photo. Or Brad Pitt posted a photo. Millions of people have to be sent messages. What are you going to do? You're going to push messages all the way? Broadcast will kill your system. In that case, apart from push, you also have? Exactly. You can, like, periodically pull. Every 3 minutes, maybe you pull for is there any new notification which belongs to me? And then the server can take care of that. Good thing in Instagram is it's not a real-time protocol. You don't need it immediately. Yeah, while in a chat system, when a person has sent a message, I'm about to die, that time you might want to see that, yeah. Although you have better things to do, I'll tell you. Okay, what did we learn? Expect changes to happen, and most importantly, expect failures to happen. Okay, instead of keeping things simple, try to keep things extensible. It's also something that LinkedIn has spoken about a lot. Their current database system, Voldemort, had a serious issue with keeping things too simple. Idempotency and quorum, you guys can look it up, but it's mainly about making sure that even if things fail, they don't completely screw up the entire system. Okay, documentation, who's going to do that? And in the end, test cases, this is basically the main point of the whole presentation, I guess. Just write test cases to make sure that the behavior that you expect is maintained as the system progresses. Okay, and the trade-offs that you made initially don't have any hidden assumptions. Okay? Nuclear explosion, all right. Thanks.